We're going to look at example 4A in your section 4.3 notes. We have three parts to this problem. First off, we would like to locate the critical points of our function. So that involves the first derivative. So if we go ahead and take the first derivative here, it's pretty easy. We get negative 2x minus 1. And to find the critical points, we need to set the first derivative equal to 0. Okay, so easy to solve here. We'll get a critical point of negative 1/2. All right, now for part 2. We'd like to use our first derivative test to find any local maximum or minimum values on our interval here. So our interval goes from negative 4 to 4. Okay, so we're trying to see if this critical point of negative 1/2 is a local min or a max. So we look at the signs in our first derivative. Probably the easiest value to plug in would be 0 on this side of negative 1/2. Okay, if we plug in 0 here, we'll end up with negative 1. So we have a negative, okay, or a decreasing part of our function. Okay, we can plug in something like negative 2 over here. If we plug in negative 2, we get 4 minus 1. That's a positive answer. So this is the increasing side. Okay, so we're going to be increasing on the left side, and then we're going to be decreasing on the right side. So that makes our negative 1/2 critical point that we found a local max. So F has a local max at negative 1/2. Now we still need to find the y value. Okay, so this is pretty easy. You could definitely plug it into the function. You also can use your graphing calculator to help you out. So when I did this, I went to my table set feature, so second window to get there, and negative 1/2 won't generate in my table. So I went down to the independent, that's your x variable, and I changed that to ask. Okay, and then I went to my table, and then now I can plug in negative 1/2 or negative 0.5 rather, and I can see what the y value is going to be. It's going to be 2.25. Okay, so there's our local maximum value. All right, last part here is to figure out if there's any absolute maximum and minimum values. We know that there's going to be both an absolute max and an absolute min value because this is a closed interval and our function is continuous. So we need to evaluate our function at the critical point, which we've already done, and then also at the endpoints. So I'm going to go ahead and write down our critical point. So f of negative 1/2. We already got 2.25. If you prefer a fraction, you can write that as 9/4. Okay, I need to evaluate my function at negative 4. Okay, once again, I can use my graphing calculator to help me do this. So negative 4, I get an answer of negative 10, which I'll write down in a second. I'm going to go ahead and do the other endpoint of 4, and I have a negative 18 there. Okay, so negative 4, we got negative 10, and positive 4, we got negative 18. All right, so we can see that our high point or our absolute max is the first one that we have. Okay, and then we can see our absolute lowest point is going to be right here. Okay, if you prefer to write those in ordered pair form, you can do so as follows. You can say that negative 1/2 with the 2.25 value is the absolute max, and 4 with negative 18 is the absolute min. Okay, so at this stage we have all three parts of the problem done.